All right, so for this one, they give you the differential equation and they give you this initial condition. But even if you do separate this, which you can separate it pretty easily, you're going to get dy equals sine of x squared dx, and you integrate both sides, you are going to get y over here on this side, but over here, you are not going to be able to integrate that. Because if you try to do like a u du, your u will be x squared, which makes your du to x dx, and you can't, we can put a 2 there, but we can't put the x into that equation. So we do not have any methods that are going to let us integrate that. So what we're looking at, though, is we see some answer choices here that we still have the integral in the answer. So that those two are the ones that are going to be possibilities. They tell us y of the square root of pi equals 4. So pi is sort of our starting point, right? So if we want to find a value for this, what we can do is we can have y of pi, which would be 4, and then we could add the amount of change from square root of pi to whatever variable we're wanting to plug in. So that will look like this, the square root of pi to x of sine of t squared dt. They use a t there just because those variables can't match for that. So we don't know how to actually integrate that, but we can set it up like this. Does that make sense on that? Okay. If they had given us something like y of 0 equals 4, then it would be C for that. So it's wherever, that bottom limit is wherever the x value you're starting from. Okay, which other ones do we need to look at? One? Okay, so this one is a calculator active problem. I'm going to grab my calculator. You can tell just by the answer choices you're probably going to need it. For this problem, you're going to have, you got dy over dx equals e to the x minus 1 over e to the y. And so you can, basically you're just cross multiplying is what you're going to do here. So you'll get e to the y dy equals e to the x minus 1 dx. And you will integrate both sides, which will give you, here on this left-hand side, you just get e to the y again, because e to the y is its own integral. And over here on the right-hand side, you'll get e to the x minus x plus c. And so they give you the initial condition y of 1 equals 0. So that's the point 1, 0. You're going to plug it in. So e to the 0 equals e to the first power minus 1 plus c. So this is 1 equals e minus 1 plus c. We could add the 1 there and then subtract that e. So we'd get 2 minus e for our c. If you want to, you can use a decimal for that as calculator active. So I've got e to the y power equals e to the x minus x plus 2 minus e. Also, I could have solved that for y first if I wanted. It just seemed easier to me, I think, to go ahead and plug in and find c. Because I really do need this solved for y to make it quickest. So, but that can be done just by taking natural log of both sides. But what you got to be careful with is natural logs don't cancel on that right-hand side. You're going to have natural log of e to the x minus x plus 2 minus e. And so if you want f of negative 2, you are just going to do natural log of e to the negative 2 minus negative 2 plus 2 minus e and let's hit the green button before we hit enter there. And it's going to give us 0.34858, which is going to be B for that. Okay. Questions on that one? All right, which other ones do we need to look at? 14. All right, so for 14, you have got d capital P over dt equals, or plus P equals 10. And I don't think we can separate that, is the problem with this one. So this one, because you got that plus sign with that P, if you multiply both sides by dt, you would have a P times dt here. Because like when we multiply by dt, we're multiplying that whole side by dt. It would have to be distributed. That puts a dt with your P, which you can't have. But then you can't divide it off again because it'll end up back over here. So what you're looking at, you're not able to separate. So you're not going to separate for this problem. You're going to check your answer choices. One looks like a fairly difficult, or A looks like a fairly difficult derivative, and I would rather stay away from it if I can. So I would probably start with B, C, or D and try it. So because P, for B, you got P equals 5 minus e to the negative t. So dP dt would be 5 plus e to the negative t. There, the derivative of e to the negative t is itself, except for you got to do chain rule and multiply by negative 1, which will make this positive. So if you plug it in, dP dt would be 5 plus e to the negative t plus p itself, which is 5 minus e to the negative t. And this is supposed to equal 10. And these cancel. See, that one works. But the initial condition probably does not work. Yeah, that's the initial condition. So actually, what we probably should check on all of them first, because I'm not thinking about initial conditions.
I'm pretty sure I got them separately. I subtracted the p to where it was the dp and the dt, minus p, and then moved it back over and moved it to dt.
You can. You're right. You can get them to separate. You can. Which is probably going to be faster. We could continue. That's what I'm doing here. P of 0 equaling 4, if I plug, or would it be? So if I plug in the 0 into all of these equations, like when I plug in 0 here, no, you still get 4 for all that. No, you're right. We got 10 minus p, we will multiply by dt. right? Because you're going to get 4 for that one. How do you know it's not going to be an answer then? I don't know. I've got to think a little more about why what I'm doing is not working for that. Because if you plug in 0 right there, you will get 4. And it looked like the derivative just worked too. Maybe I messed something up. So we got dp over 10 minus p equals dt, which when we integrate here, our u would be 10 minus p, so the du would be negative 1 dp, so you just have to put a negative here and a negative outside. And so when you integrate that, you're going to get negative natural log of the absolute value of 10 minus p equals t plus c. I would get rid of that negative first by dividing off by that negative 1 natural log of the absolute value of 10 minus p equals negative t. I'm going to leave it a plus c. You can change it minus if you want. It won't hurt, but c's kind of absorb everything that's done to them. You got e to the power, e to the power. So 10 minus p is going to equal ce to the negative t. Subtract 10, negative p equals ce to the negative t minus 10. Divide by negative 1. C kind of absorbs that there. We got ce to the negative t plus 10. And then we want to plug in for our initial condition. So we will plug in 4 equals ce to the 0 plus 10. So we subtract 10. Negative 6 equals c. So we get p equals negative 6 e to the negative t plus 10, which can be written like answer choice C. And I need to go back and think more about why what I was doing was not working. But I'm not going to spend time doing that right now, so I can look at some other ones. 12? Yes. All right. For 12, we've got dy over dx equals 3x squared minus 1 over 2y. And for this one, you can more or less just cross multiply, because when you do that, you're going to have 2y dy equals 3x squared minus 1 dx. And so you will integrate both sides. And so on the right-hand side, you're just going to get y squared. And on the left-hand side, you'll get y squared. On the right-hand side, you're going to get x to the third minus x plus c. And you could square root both sides to solve that for y. When you square root both sides, technically there should be a plus or minus right there. But if I look at my point that I'm going to plug in, f of 1 is supposed to be positive 4. So which one should I choose for this particular solution? The positive, right? Because the only way we can get a positive 4 is if this is positive. If f of 1 was equal to negative 4, I would choose the negative for that. So you want to think about what your initial condition is to choose that positive or negative. And so now you can plug in 1, 4. So you'll get 4 equals the square root of 1 cubed minus 1 plus c. This is going to be just 4 equals the square root of c. If we square both sides, we'll get 16 equals c. So we get y equals the square root of x cubed minus x plus 16, which is if what you could always cross multiply, just sometimes it's not helpful. So in this case, where I have everything like on that diagonal are all y's, and then all of our stuff here is x's. If you just cross multiply, it'll get you there the fastest. Yes, it'll also work on 11. And we could do it like we've done for the other problems, like we could multiply by dx, and then you'd have dy equals 3x squared minus 1 over 2y times dx, and you got to get rid of that 2y, so since it's in the bottom, you would have to multiply by 2y over here, which will get you to that same spot. But if you notice, like, your diagonals have the right variables, you can just cross multiply from the beginning, and it'll save you a little time and a little brain power. Yes?
Why does C not get absorbed by square root?
It is because if you were just taking the square root of the C, it would be fine. But if you have the square root of things, like if you have square root of 4 plus 9, that is the square root of 13. It is not 2 plus 3. You can't take the square root of those things separately. So since you are taking the square root of that whole entire side, which is the way you have to do it, you can't take the square root of the pieces individually. It has to stay underneath that square root.
Even when you get it down to just square root of C?
You mean like here?
Like when you get it to where you square both sides, like where it's 4 squared
Yes.
and square root of C squared, would square root of C not just be C?
At this point, you've plugged in your initial condition and you're solving for C. So once you have done that, C is no longer going to absorb everything. Does that make sense? So in your initial part where you're solving the equation, whatever you do to C just kind of gets absorbed for the most part. But once you plug in your initial condition, that's not true anymore. Treat C as a variable because C is what you're solving for at that point. So like in this last step right here, if we need to divide both sides by 2, we would divide both sides by 2 and do that for our C.
It removes all the confusion if you just don't square root both sides to find C.
Mm-hmm.
You can just do 16 equals 1 minus 1 plus C. C is 16, and then just square root both sides.
Yeah, you could also do that. That's another good point. So it should work either way for that. So if you find C first and then solve for Y, you should get the same answer. So if we found that to be 16 first, obviously once it's a 16, we would not just take the square root of it off on the end there. Okay, good question. All right, other questions. Which ones do we look at?
Uh,
13? Probably. Did you have C as your answer? Yeah. So on that as well, whenever you're doing something, it's the same. Raising something to 1/3 power is a cube root. It's the same sort of thing. It has to still stay inside. Another way you could avoid like that mistake is also just to find C first and then solve for Y. Okay, other questions? All right. On the review, I just want to make sure. Number 6 on the review, where I have got dy over dx equals e to the x plus y. A and B, it doesn't matter. I don't think you don't really have to separate, but C, when it asks you to solve, you're going to have to separate that. How are you going to separate that? Very good. You're going to have e to the x times e to the y. So then you can multiply by your dx, divide by that e to the y. You're going to get dy over e to the y equals e to the x dx. Let me warn you of something here. It is very tempting every time you have a fraction to just do natural log. You don't do natural log on this problem. This is e to the negative y dy equals e to the x dx. Same thing would be true like if you get something like 1 over y squared dy equals e to the x dx. You won't on this problem. This is just a side note. But if you had something like that, it's not natural log. We get it's really easy to think anything in the denominator is going to become a natural log. This would be y to the negative 2 dy equals e to the x dx, and then you would integrate using power rule. It would not be a natural log problem. So you would separate like this, and then you would integrate both sides for that. I think. Let me check.